Hi guys, good morning, good afternoon, whichever time you're watching this. I hope you're keeping fine. Some of you are working well, but some of you are not really doing what you should be doing. You need to be working a little bit harder, please. Right, so today's topic, we've done this before, we're just recapping it. It's experimental probability. An experimental probability we use when we don't know what the probability of certain outcomes is before they happen. So for instance, when we flip a coin, we know beforehand that the probability of getting heads or tails is 50%, assuming there is a fair coin. Or when we roll a normal dice, before we roll it, we know that the probability of rolling a 6 is 1 out of 6, assuming it's a fair dice. However, there are situations in which we don't know what the probability of each outcome is going to be beforehand. So for instance, the color of different cars passing down the street, we don't know what the probability is going to be. So that's why we run an experiment. We're going to sit on our front door, count how many cars pass by our front door, record the color, and use that as a guide to work out the probability of a car passing by being of a certain color. The nature of experimental probability means that the more you run the experiment, the more cars I record, the more accurate my estimate for that probability is going to be. So if I only record 10 cars, I am not going to feel very safe or very secure or very confident about my calculated probability. Whereas if I record 300 cars or 1,000 cars, then I'm going to be more confident about my estimated probability. So here, I've got a table of different colors of cars that pass by my door. So I got this, you've got this on the PowerPoint that I've made available for you as well to have a check. So you got two resources to help you with this. And the first thing you need to do with experimental probability is figure out how many cars we recorded in total. So here, if I add all of this quickly, there were 350 cars that I sat there with a clipboard taking notes, okay? So I have 50 red cars, 80 blues, 30 greens, etc, etc. Then, with your calculator, you can find what we call the relative frequency. Apologies for there's a reflection there, maybe that's a little bit better. It's a dark day today. If I don't have the light on, you're not going to see anything. So the relative frequency is how many cars were red, 50, out of the total. So it's 50 out of 350. With your calculator, you can change that into a decimal, and then you should know how to change the decimal into a percentage, but I'll leave that to you. How many cars, what was the relative frequency of blue? So how many cars were blue? 80 out of 350. And we can do that with every color. So once I've got my relative frequencies, I've calculated the probability of any particular car passing by my door being a certain color. So typically this would be the first part of the question that you need to do, the first bit of the calculation. And then usually there's a follow-on, and it would say something like Gemma is sitting outside a bar, and if 200 cars pass by the bar, how many cars would she expect to be white? Okay, so we have 200 cars now. So we've moved on. So we know our calculated probabilities, but now we're sitting at a bar, 200 cars pass by, how many do we expect to be white? Well then, you get the relative frequency of white, which is 40 out of 350, and all you have to do is multiply that by the number of cars, and that's it. So 40 out of 350 multiplied by 200. I haven't got my calculator with me, but I should. You can work it out, and that should be your answer. Typically in the exam, the numbers are worked out, so you get an exact number as an answer. Here, in the case that we have a decimal, you will have to round as best you can, sometimes up, sometimes down. But basically, that is it. That is experimental probability or relative frequency, which is what I think your book calls it. But anyway, something simple to get ourselves into the flow of these online lessons, and we'll try to recap trickier topics going forward. Anyway, I hope that was clear. You've got the PowerPoint, you've got the work. Take care, work hard, and I'll see you soon. Bye.